Hey, great. So our learning target today is I compare linear and exponential change. So we're going to compare what happens when you have the same growth all the way and what happens when there's something that kind of blows up or is an exponential change. So we're going to compare two different bank accounts and your options where you want to deposit your money. So it's really dependent on how much time you want to leave the money in the bank. Okay, first we have TCF Bank. You earn $100 at the end of every year. So the situation is going to be this, that we're kind of missing a piece there. It's supposed to say somewhere, oh, right here. Thank you. Sorry. Which bank? The situation, you have $1,000 saved. So there's your beginning amount. And now you need to figure out which bank you want to invest your money in. You can choose from the following two banks. You can choose from TCF Bank, where you have $100 at the end of each year, or Wells Fargo Bank, where you earn a 6% annual interest. So one of them is going to be linear, the same amount every year, and one of them is going to be exponential. So the first example, TCF Bank, you start with $1,000. It's just a y equals mx plus b situation. Your beginning amount is 1,000. Your slope is 100. So we're going to have an equation of y equals 100x plus 1,000. Go ahead and write that down. Y equals 100x plus 1,000. All right, so then we have Wells Fargo. Wells Fargo is the option of a 6% annual interest, but you're building upon each other every year. So it's kind of compounding there. So you still have growth happening. It's a 6% growth, but you're going to have the equation y equals a times b to the x. A is the beginning amount, 1,000. B is a growth of 6%. Now you got to think about that 6% really means that you get 100% of your money back plus 6% bonus, so 106%. So we write it in our equation then, our growth becomes y equals 1,000 for the beginning, and that 106% in decimal form is 1.06 to the x power. Okay, so we're going to graph these two. So the TCF Bank is going to be a straight line graph starting at 1,000. Nice straight line, right? Line there. The slope is 100. Just keep increasing 100 every year. Wells Fargo is going to have a different growth. It's going to still start at 1,000, but it's going to kind of explode in its growth graph. It's going to be exponential. So we have a little bit difference in the way our graphs look. Okay, so we're going to get some data points first. We're going to do all our rounding to the nearest cent. So we have TCF Bank with the equation y equals 100x plus 1,000, and then Wells Fargo is y equals 1,000 multiplied by the growth of 6%. You get all 100% back plus a 6% bonus to the x power, where x is the number of years regardless of the situation. So as we start to graph then, we would just use substitution. We would plug in a 0 for our x value here. So after 0 years, no, you haven't had any time go by, you just have that $1,000 in the bank. No change there at the beginning of the account, just a 1,000. It's a little bit different though as we start to go. So same scenario here. We plug in a 0. We have 1,000 multiplied by 1.06 to the 0 power. And again, that's just a 1,000. So at year 0, right at the beginning, it doesn't matter which account you're in, which bank you go to, it's just $1,000 right at the beginning. But then 1 year later, 12 months go by, and what changes? Well, after 1 year in this account here, we get another $100. So we'd have $1,110 because it's the same slope all the way down this graph. $100 at the end of every year. That's just how it works. At Wells Fargo, though, you would substitute a 1 into the first power, so you get a 6% increase. So 1,000 multiplied by 1.06 to the first power, rounding to the nearest 10 of us, or to the cent, which we don't have to worry about in this question, is $1,060. So you can still see that at this point, TCF is a better deal if you're only going to keep the money in for 1 year. But over time, we're going to see that the other bank is going to grow. So now we go year 2, we put another $100 in here, which is 1,200, linear growth, same slope. And then we go over to the other bank on year 2 here. So we have 1,000 multiplied by 1.06 to the second power is $1,123.60. Okay, so then we're going to compare the values there. So where is it a better deal? Still keep your money at TCF. All right, so we're going to keep going. Okay. So year 3, we put another $100 in. And then we plug in a 3 here. What happens at year 3? So we multiply that because the money's compounding now. It's building off of each other. It's $1,190, $91.02. Double check that. Round that to the nearest cent. We're going to keep adding $100 here, $1,400. And then we plug in year 4 here. So as we start to solve, then we plug it in. So we have 1,000 multiplied by 1.06 to the 4th power, and we get $1,262.48. Again, TCF still is winner, winner, chicken dinner there. We plug in year 5, we have another $100 growth. We talk about power of 5 here. So we have 1,000 multiplied by 1.06 to the 5th power. Our value, our output value there is $1,338.23. Still a better deal at TCF. Okay, so now we're going to keep working those tables as we work down. So I'm going to go ahead and just give you some time to work the table all the way down. And then I'll pull over the answer key in just a second so you have a chance to compare answers. So go ahead and work. You can go ahead and pause the video at this time. I'm going to just keep the video running, but I will be silent for the next few minutes as you're working through the table. Remember that this has the same slope all the way down, so we're just adding hundreds. This one, you're going to have to use your calculator to substitute the years 6, 7, 8, and so on into that formula. Rounding to the nearest tenth of a cent. Go ahead and work. I will be nice and quiet here, and I'm going to drag the answer key over so it's available to you as you're working. And I'll be nice and quiet, so go ahead and work. All right, so if you're not quite ready to do the graphing there, you might want to pause that video. So you can see that there is a change that happens over the course of time between the two banks. So we're looking to figure out when would it be a good idea to bank at which place where you're going to get the most bang for your buck, the biggest growth in money. So as we work through the graph, you can see that in the front end of this, in the first couple years of this, it's it's a tie when you put the money in, which shouldn't make sense to you. But then at beginning of time here, it's cheaper at TCF Bank for a long time, or not cheaper. I'm sorry. You're making more money, making more money, making more money. And then we want to know, when does the switch happen? And you can see that the switch does happen eventually here at year 18, where you actually start making more money after year 18 as if you go the exponential route. So the question really is, how long are you going to keep the money in? And it looks like the cut year is really at the end of year 17 is where you kind of want to make the cut. If you know you're going to keep it in that money in the account for 17, more than 17 years, you should go the Wells Fargo route. So nice linear graph happening here. This is an exponential graph starting at 1,000 and growing quickly. So you can see that there is quite a change where one grows faster than the other over the course of time. So if we were to graph these, so we're going to go and flip over now to page 22. If we were to graph these, we would see that they both start at 1,000, both starting at 1,000. And you would want to plot those data points. So you're going to, you're going to have that nice linear graph happening with the Wells Fargo Bank. And it's pretty easy to graph that one because you can just go up by 100s on your plot here. So I didn't write all the numbers in, but you can just go up by 1,000 or 100s, pardon me. I kind of have a mess over here, so I'm going to start over. So you can see that I broke the graph, so I'm going to start at 1,000. And then I'm going to go up by 100. So 1,100, 1,200, 1,300, and so on. So when you graph that, you're going to graph both of those. You should end up with a graph that looks something like this. So I'm going to give you some time to work through that. I'm going to kind of go quiet on the video so you have a chance to graph. One is linear, nice straight line graph, and the other one is exponential. You do not have to graph every single one of those data points, but you have to graph enough to kind of get an idea of what the arc looks like for the exponential and what the line looks like for the linear. So again, you don't have to graph all of those, but get enough to give you kind of a good taste of it. So I'm going to go ahead and get quiet again on the video. You should be plugging away on those graph data points. Go ahead and work on the graphing of those two on page 22. So you should keep graphing there, and then we're going to answer those questions on the bottom, page 22. All right, so I'm going to start answering these questions here on the bottom. So describe the relationship for TCF Bank. So one thing that you should notice about TCF Bank is that it is linear. It's a line because it has that same slope of 100, that same growth, and that it starts at 0, 1,000. So there's just some things to point out there. Starts at 0, 1,000, same slope of 100, that's the increase. You'll also, when you compare that to Wells Fargo, you'll notice that Wells Fargo also starts at 0, 1,000. They have the same beginning amount, which is a good thing to notice, but their growth is different. This one's going to grow exponentially, so it grows in that non-linear graph. So it's kind of a explosion that occurs over time. Okay, so we have that exponential growth versus that linear growth, so a little bit different in the way it grows. So if we look at the graph, you can see that over the course of time, we have winner, winner, chicken dinner. So if I go ahead and highlight in blue, you can see that you're making more money at TCF in this blue line all the way until you hit this intersection known as a POI. And if we follow the yellow line, you can see cheaper, cheaper, not as much, not as much, not as much, not as much. And then an explosion happens. And then, whoops, that wasn't supposed to happen. And then it takes over right here. And now you're making more money at Wells Fargo. So we're going to go ahead and write that or represent that here. You also see it happening in the table that the magic number really happens here at the end of year 17 is when that switch occurs. So you really got to be thinking about how long do I plan on keeping the money in the bank. So as I look at this, I'm going to say that if you're going to keep the money in the bank really from year 0 to year 17, so from year 0 to year 17, sorry, I'm having trouble writing with this pen here. From year 0 to year 17, you should go with TCF Bank. It shows it in the table. It shows it in the graph. You should go with Wells Fargo if you're going to go 17 or more years, or really like that 18th year. That 18th year is when it kind of kicks in. So, or I think I'm gonna actually say more than 18 years, more than 17, because 17 we still want to go to TCF. It's not really a tie there. It's not like they're equal in value at year 17. So I want to be careful on how he states that. So year 0 to year 17, you should go with TCF. If you're going to go more than 17 years, you should go with Wells Fargo. So our graph then would look like this. We would have 0 years to 17. And definitely go with TCF. If you're going to go more than 17, you should go with Wells Fargo. So go ahead and write that down. Take a look at that. Make sure that's clear what I'm asking you to do there. All right, guys. So for homework tonight, you should really you could possibly work on pages 23 through 28 because those are going to be things that we're going to be doing in the upcoming days. So why don't you start working on pages 23 through 28. Have a fabulous night.